was to make a documentary and try and help people to understand that this is here. That was our purpose of coming.
My name is David Slauson. I'm the Chairman and CEO of Sterling Energy Systems. SES has the latest 21st century technology that enables us to produce electricity with no fuel cost or pollution. I sometimes refer to this technology as the solar thermal nuclear energy technology because we're essentially harvesting the free energy from the sun, from that nuclear furnace that's 93 million miles away. The sun represents America's most, or the world's most, strategic energy resource that has yet to be capitalized on and tapped into. With the SES technology, we're able to do that and to deliver energy, peak power to the market, augmenting existing power supply at competitive prices with conventional energy. Our technology is very much like a large magnifying glass. We have a large 38-foot diameter dish, and cantilevered out in front of the dish is a power conversion unit that is made up of a solar receiver cone and a Stirling engine. And much like the magnifying glass that you played with as a child, we're laying down an even heat flux on the external surface of the Stirling engine. We heat those tubes by the sun's energy. We're heating a hydrogen gas that expands and runs 4 pistons and turns a conventional crankshaft, which in turn turns an electric motor, and we are able to produce that electricity with no fuel cost or pollution.
My name is Chuck Andraka. I've been with Sandia National Labs developing dish Stirling technology for the last 20 years. And we have a collaborative project now with Sterling Energy Systems to take this 15 to 20-year-old technology and bring it to mass production. But the biggest thing with this design for us is the accessibility of the engine. You saw up there, they're trying to get to this compressor unit here and this pressure transducer, and the radiator comes all the way to this point on the other system. So it's very hard to work with this. In fact, getting to the compressor head, we have to actually remove the radiator. It's 4 bolts to service the compressor, but it's 2 hours to take on and off the radiator. So this is a much better design for serviceability issues.
Was this is your main support, and it's into an existing old position on this?
Exactly.
That was what the other was actually also bolted to?
Right, the arm is very similar to the old one. It's a 2-point soft mount on the engine, basically grabbing it at its center of gravity. And there's actually a 3rd mount on the generator because it's cantilevered out to the side there. But everything green here is the Stirling engine. This is the cold end. This is very much like a automotive bottom end. You have crankshafts, you have connecting rods, you have an oil sump, and then the hot end is from this point forward. This is where the sunlight is focused on. We have high pressure hydrogen shuttling back and forth in these tubes, and this is where the heat is getting put into the working fluid of the engine.
Now, how long ago were those tubes fabricated?
This is probably early 80s, early to mid 80s. SES is in the process right now of making 5 additional sets of heater heads for the new engines. So they're doing fresh fabrication now.
Design changes, or is that?
Very little design changes. We are looking at some parts in this are high temperature, high strength alloy. And an alloy was selected in the early 80s for cost reasons because of the lack of availability of some components of some high temperature alloys, such as cobalt. No, it's XF818, and that's a specialty alloy. It ends up as very hard to machine. So we've got new heads made of the XF818, but we're looking at other options. You have to look at the total system cost. You can't just look at the cost of the raw materials. We've got our sandia metallurgists involved in helping to evaluate that material's machinability as well as evaluate alternative materials. Right now, the engines SES is making are, for the most part, identical to these engines, more modern transducers and sensors, looking at some of the materials issues and what changes ought to be made to reduce the manufacturing cost.
And we're also able to store the sun's energy. We can make electricity off our electric motor. Now we can move that electricity through transmission lines and supply the market. We can also store the sun's energy by using that electricity through an electrolyzer and split water. So now we have another medium of transferring the solar energy to the market. So we can move energy through electricity or through a medium of hydrogen fuel, which can be transported through pipelines or by truck transportation. So now if we were to build large-scale solar power plants in the southwestern United States, I can move that energy anywhere in the market. And it can be used for not only electrical power generation, but it can be used for the transportation sector as well. And how this compares with cost, if you look at the coal industry, you've got major externality costs associated with the mining of the fuel. You've got healthcare costs related to the pollution that it creates in the environment, the contamination of our soil, water, and the food supplies that we eat. Out of the roughly 1,100 coal plants we have around, there's 48 tons of mercury put into the environment every year. So when you add up those costs, you can clearly see that harnessing the free energy from the sun is a great alternative. And it's in its infancy, so it's a huge, vast market opportunity. And I welcome all industries, whether it's coal, oil, natural gas, or nuclear industry, to really look at the sun as a strategic energy resource that's in its infancy, and there's huge investment opportunity. SCS is willing to partner with any company that has an interest. And again, if you look at, again, our advantages is that we don't have a fuel cost. So using the coal as an example, we don't have that fuel source to mine and transport. We don't use natural gas, so we don't have that fuel cost or the inflationary costs associated with natural gas. And then if you were to compare us with the nuclear energy solution, granted, nuclear energy is great because you have no carbon emission, but the problem is you've got very expensive installed cost per kilowatt hour. It would require subsidies to permit and build new nuclear power plants. You've got a long permitting time. You've got environmental catastrophe guarantees that are bankrolled and guaranteed by the U.S. taxpayer. And when you mine uranium and create nuclear waste, well, you have to put that somewhere. So that's all added costs. You might call those externality costs. And so clearly the solution that's most cost effective is harnessing the free energy from the sun.